Hello and welcome everyone here to our GDG Lahore event. Normally इसको आपको हमने देखा होगा कि हम in house workshops हम करते हैं, लेकिन this is a virtual one and we're excited to have you all here. So first of all, I will give my own introduction and this is Salman Arif. I've been with this GDG community for the past 3 years now, and for me personally, I've grown a lot as a person and as a professional, and not only me, my teammates, they've all helped me in making the person that I wish to be. So yeah, just talking about myself, we'll just start. So our first talk is about scaling your AI with Kubernetes, as you may have seen from the socials. But before moving towards that, I would just want to talk about some of the stuff that we have been doing. So in order to know what we are as a community, so GDG पूरी दुनिया में इनके ढेरों चैप्टर्स हैं, और पाकिस्तान जो है वो कोई डिफरेंट नहीं है. पाकिस्तान में भी मुख्तलिफ इनके चैप्टर्स हैं, जिनमें एक GDG लाहौर भी एक प्रोमिनेंट चैप्टर है. तो इसकी ख़ास बात यह है कि हमें 10 साल से ऊपर हो गए हैं इस कम्युनिटी को चलाए हुए, और ये थोड़ी सी मैंने जो है ना लास्ट मिनट में मैंने आप कह लें एक स्लाइड्स मैंने इस तरह से बना के रखी हैं, जिसमें मैं दिखाना चाह रहा था कि किस तरह से कम्युनिटी जब इकट्ठी होती है किसी चीज़ के लिए तो वो कितना इम्पैक्ट क्रिएट करती है. तो कुछ मैं झलकियाँ दिखाना चाह रहा था, जिसमें हम ना सिर्फ ये कि लाहौर में इस तरह की कम्युनिटी, बल्कि ऑल ओवर द वर्ल्ड भी एक हम GDG जो है एक वर्ल्ड वाइड एक कम्युनिटी है. और बस इसमें रिसेंटली हमने जो डेफेस्ट हमने करवाए हैं, तो मेन हमारे इवेंट हमारे डेफेस्ट होते हैं, हमारा IO एक्सटेंडेड होता है. तो मेन ऑल ओवर फोकस ये होता है कि हम डेवलपर्स हम फोकस इवेंट्स हम करवाएं, और इसमें यह है कि जो टेक्निकल एस्पेक्ट्स होते हैं हमारी प्रोग्रामिंग वाली साइड पे, हम उनको फोकस करें रादर देन just talking about technical just talking about tech side or just talking about अभी आजकल AI चल रहा है बहुत ज़्यादा, तो हम AI के हवाले से बात करने के हवाले से अगर हम AI के हवाले से बात भी करें तो हम चाहते हैं कि हम इसमें जो एक्चुअल टूल्स जो हेल्प करते हैं हमें इन मॉडल्स को अब एनहांस करने के लिए, हम उन टूल्स के बारे में टेक्निकल डिटेल में हम बात करें. तो इसी ज़ुमरे में मैं यही आगे टॉक को स्टार्ट करते हैं. टॉक हमारी है शहरयार नसीर की. वो अपना इंट्रोडक्शन बेहतर तरीके से खुद ही दे सकते हैं. तो उसमें थोड़ा सा मैं उनको इंट्रोडक्शन का हिस्सा से दे दूं कि अराउंड 15 ईयर्स का उनका एक्सपीरियंस हो चुका है, और आज हम इनकी टॉक का मेन मकसद है कि आपकी एप्लीकेशन जो है, आपकी की जो AI एप्लीकेशन है वो किस तरह से हम उसको स्केल कर सकते हैं विद द हेल्प ऑफ Kubernetes. सो ओवर टू शहरयार.
Thank you, Salman. I think I can add my slides to the screen. Okay. तो अस्सलाम वालेकुम, कैसे हैं सब? मेरा नाम शहरयार है. I am a software architect and a technology consultant. I've been in the software industry for about 14 years now, with a strong focus on web and cloud and deep knowledge of real-time and distributed applications. Over the years, I've been very lucky to have had worked with some amazing companies solving very interesting problems using technology, including Apple, Superlist, Slab, Allocator One, The Score, and a bunch of others. So I've published multiple famous libraries, and my work has been featured on various publications, newsletters, podcasts, and other developer communities. And with over 75,000 points on Stack Overflow, I also rank among the top 5 developers from Pakistan. Stack Overflow used to mean something a lot a while back, with the rise of AI applications and a lot of these AI tools, तो अब developers obviously इतना use नहीं करते. अच्छा, तो let's start with the agenda for today. आज की talk के 3 main sections हैं. First is the state of AI, where I'll evaluate the current AI landscape, the types of AI applications, and which of them is the most popular type that is being developed these days. Second is scaling challenges. इसमें हम ये देखेंगे कि AI applications को normal apps के मुकाबले में scale करना क्यों मुश्किल है, और उनकी and what can we do. And the third is Kubernetes and how it can help us scale AI applications that are usually hard to scale. Finally, we'll end with a Q&A session. So I'll try to answer as many questions from the chat. So I guess we can move on. Before, one of the things for today is we do have limited time. So while I won't get a chance to go into code, but if we do get good feedback, we do plan on doing an extensive hands-on workshop on this topic in the future. So let's start. What does the AI landscape look like today? तो हम सबको already current market का और state का पता है. AI use or growth has been unprecedented. AI is dominating the every piece of technology and business news. And if you look at the stats, we can see at least 72% of businesses have adopted AI in some shape or form, at least in the Western world. AI की dominance और AI की usage rest of the developing world में भी increase कर रही है. And that is also sort of like a lagging factor, lagging indicator, जहाँ पे हम देखते हैं कि क्या usage, मतलब कौन सी communities हैं, कौन से tools हैं जो कि AI की overall usage को push कर रहे हैं. Interestingly, subcontinent, including India, Pakistan, is one of the places in the world जहाँ पे AI की usage बहुत ज़्यादा है after the Western world. Some other stats that I want to quickly share is 700 million plus people have used AI apps and tools in just the first half of 2025. And we can already see in the news that insane amounts of capital is flowing into new AI tools, startups, and infrastructure. And the market size is expected to reach over $1 trillion by the end of the decade by some estimates. Even the lowest estimates put it around 500 billion. But we can see कि कुछ आपकी बड़ी जो analysis और इस तरह की reporting companies हैं वो ये expect कर रही हैं कि that the usage will grow beyond $1.34 trillion. So because of all of this, that actually brings us to the actual systems that run AI. Business or investments or पैसों की सारी बातें अलग. We are the engineers, we are the programmers, the developers who build these systems and make these AI applications जो users use करते हैं. And to handle this expected demand in the future, हमने अपने systems को appropriate तरीके से structure और design करना है. So, but before we talk about that, we also need to understand कि AI की applications हैं क्या, right? Before we think about actually scaling these AI applications, we have to, contextualize the conversation. We need to know what are the different types of AI applications and systems being developed today. And if the application that you are developing falls into those categories, and if, you're going to face scaling challenges when actually growing those applications. So AI applications का पूरा spectrum है, right? So there's not just one type of AI app, there are many different kinds. And AI isn't even a new concept, right? There has been a lot of development into the AI ecosystem over the past 5 decades, 1970s, 1980s से मतलब इस पे effective काम चल रहा है. So when you talk about automations, सबसे पहले तो ऑब्वियस सिंपल programmatic workflows or automations हैं, right, which can be considered AI by the average Joe, but they do not matter for our conversation, so I'm just gonna skip those. लेकिन उस स्पेक्ट्रम अगर हम इनको स्किप करके हम आज की जो प्रॉपर AI एप्लीकेशंस के ऊपर हम फोकस करें, जो स्पेक्ट्रम एट बेसिकली फॉल्स इनटू 3 कैटेगरीज, राइट. द फर्स्ट इज एक्सटर्नल API कॉल्स. तो बेसिकली व्हाट दिस मींस इज कि किसी सर्विस ने ऑलरेडी एक AI टूल बना लिया, एक मॉडल सिस्टम बना लिया, एंड दे हैव एक्सपोज्ड इट थ्रू एन API, राइट. So you do not need to develop your own AI systems. You simply make an API call to their systems, send some data, and get a response back that gets the job done. इसमें जो सबसे कॉमन है वो Gemini का API है, Claude का API है, OpenAI का API है, right? You get some credits and you make an API call with some prompt and it sends you back data. इसी तरह अगर आप Google के AI systems देख लो तो there's Vision AI, there's Document AI, which basically mean that you send it some request in form of an API call and it sends you back a response that does something, जिसमें मतलब हमारे पास वो relevant information है जिससे हम effective automations create कर सकते हैं. The second is self-hosted or custom, जिसमें आप अपने AI systems को या AI applications को खुद host कर रहे हो या आपने उनको किसी ना किसी level पे customize किया हुआ है कि you are responsible for the infrastructure or the architecture, right? फिर this is basically the other side of the coin for the external API calls. External API calls में ये systems वो already दूसरी companies ने third party services ने develop किए हैं and we use them, but for self-hosted or custom ones ये चीजें हम खुद manage कर रहे हैं. And there are multiple categories to it. Again, this one is LLMs, others are RAG systems, which basically is you combining a vector database or an embedding system with other services such as, and usually LLMs. Then there are vision models jahan pe you can do things like object detection, object segmentation, object classification. You have traditional ML models jahan pe regression aa jati hai, classification models aa jate hain, clustering systems aa jate hain, anomaly detection systems aa jate hain, and then you also have like generative models like image generation, video generation tools. The third category of the spectrum is hybrid, जिसमें a large AI system is composed of multiple smaller AI systems, right? So if you think about some sort of a complex AI app जो कि multiple चीजें करती है, it would probably compose of multiple smaller AI systems which handle each part individually very well, right? तो RAG systems sort of fall into this, जहाँ पे आप उनको vector database और embedding services को आप LLMs के साथ इंटीग्रेट करने की कोशिश करते हो. But then there are other systems too that maybe use a vision, computer vision model for maybe detecting an object. Then there's a separate detection model that, or a classified model that classifies into different subcategories. So hybrid basically means that you have multiple smaller systems or you're using multiple systems together. और हमें ऑलरेडी पता है कि इन सब में से अभी मार्केट कौन डोमिनेट करता है. That's obviously LLMs, right? Today LLMs have become synonymous with AI, and most people when talking about AI they actually do mean services like Gemini, ChatGPT and Claude. And there are multiple reasons for this, right? So जो सबसे obvious है, it's the highest visibility. Because of the efforts by OpenAI in the past couple of years, the amount of marketing and the amount of visibility that they've created around ChatGPT is what pushed everything further. और इसमें obviously एक वो new चीज का भी factor होता है कि it's doing something very cool, तो उससे visibility एक exponential growth से increase करती है. Right, and then there's mainstream adoption, right? It's because of external API systems, it's become so easy to integrate AI in some shape or form in your application that every company is doing it, right? तो हर कंपनी हर बिजनेस AI को भी अपने और LLMs को इंटीग्रेट कर रहा है अपने सिस्टम्स में, अपने बिजनेसेस में, और इसका एक रिवर्स ये है कि the platform effect, where third party services create tools and integrations and plugins for existing LLMs such as ChatGPT or Gemini, so you can integrate directly with them and you can use them. तो एक इसकी वजह से एक ओवरऑल हाइप क्रिएट हुई है थ्रू आउट, जिसकी वजह से when most people say AI, उनका मतलब होता है actually LLMs, right? And it makes sense because there's so many versatile applications for LLMs. They can do so much. Interestingly, even when we shouldn't use LLMs for things like that, right? तो इधर मैंने एक इमेज डाली है. Hopefully the text is easy to read for everyone. This is a post I saw on Reddit like 2-3 days back, and I found it so funny. I wanted to share it as part of the talk. So this is what the guy says, right? We've been burning money for 6 months, and because I'm such a hard worker, I spent my weekend going through our OpenAI usage, and we were at $1,200 a month. And I honestly thought that that was just the cost of doing business. Then I actually looked at what we were using GPT for, and it's a serious waste of money for things like extracting phone numbers from extracting emails, checking if text contains profanity, formatting JSON, and uppercasing text, right? ये वो सारी चीजें that you can do without LLMs. We already have the tools, the AI systems, the models, and not even models, just simple algorithms and simple workflows that do these things very well, very fast. ठीक है, हमें LLMs की इसकी जरूरत नहीं है यूज करने की. But he continues, I ended up just moving all of the dumb stuff to GPT-4o mini. Same exact outputs, bill dropped to $200. भाईजान ने फिर भी LLM का पीछा नहीं छोड़ा, right? He's still using LLMs for doing these basic things. यार literally हर programming language में dot uppercase या to uppercase का एक function होता है, right? You don't need LLMs for that, right? But he's happy that his spend is now only $200. So that's the current state of AI these days, right? LLM dominates everything. So when businesses and startups start building these AI applications, we run into an issue of scaling, right? अगर आपकी एप्लीकेशन 10, 15, 20, 100,000 यूजर यूज करें, दैट इज फाइन. लेकिन with the expected rise in growth and usage of these AI applications, we can see कि जो अच्छे tools होंगे, जो अच्छे AI workflows होंगे, they're gonna have a lot of demand, and then you need to scale those systems. You need to be able to meet those demands. So how do you do that? And what are the problems you face when trying to do that? So for these growing pains, right, हम अगर AI को जरा इक्वेशन से थोड़ी देर के लिए निकाल दें, we've already known over time कि scaling systems, classical systems, web apps, इनको ही scale करना मुश्किल था. But over the years, we've sort of standardized some common pain points, और उनके around tooling availability है जो कि उसको कुछ हद तक आसान कर देती है, right? So you have a bunch of infrastructure and platform services, right? So AWS, GCP, which sort of try to reduce this pain in one way or the other, right? But when you introduce AI into the mix, you realize कि वो सारी जो पुराने issues थे वो as is नहीं, जो solutions थे पुराने issues के लिए, वो solutions as is AI की problems पे हमेशा नहीं apply हो सकते, right? You have so many new challenges when scaling AI applications, and the challenges vary based on the type of AI application that you've implemented, the sort of model, the sort of model that you've implemented, the sort of integrations you have, the sort of services and training required as part of that. So they vary greatly by scope, and there's no single strategy that can be applied everywhere, right? So if I give some examples, right? So then there are some common scalability issues. There are resource bound operations, right? कि आपकी जो AI, it's very CPU intensive, or not even AI, just your application, it's very CPU intensive, it's very RAM intensive. sometimes it's network intensive, right? So if maybe you're making API calls to Gemini or ChatGPT, OpenAI, you can run into network bound limitations. Then there's over and under provisioning of infrastructure, where your expected usage doesn't meet your realistic usages of the application, right? होता ये है कि you assign like a powerful beefy server to some model, और बाद में उसकी actual usage वो नहीं होती, right? Yeah, there are sudden increases in load, and then the server is under provisioned and it cannot handle that load well. तो और उसमें एक obvious एक और common issue है, which is cost management, जिसके अंदर your costs of operations do not reflect the amount of money that you can, or do not correspond to the amount of money that you can put into the infrastructure, right? तो ये सब कुछ कॉमन प्रॉब्लम्स थी, बट देन देयर आर एआई स्पेसिफिक और इम्प्लीमेंटेशन स्पेसिफिक प्रॉब्लम्स, राइट? तो एक्सटर्नल एपीआई में मैंने ऑलरेडी बात कर दी है कि यू कैन योर ऑपरेशंस कैन बी नेटवर्क बाउंड, राइट? इट कैन बी बोथ ऑन योर एंड और ऑन द services end, right? A common issue on the service end can be rate limiting. A common issue on your end can be that you're making too many API calls, and which slows down the overall network and basically slows down your entire application. If you're using a self-hosted LLM, a common problem is cold starts, right? How do you manage that? How do you ensure that the model is ready to serve and respond to incoming requests, right? Similarly, then there are scheduling and fragmentation issues. When you're building RAG applications, either using self-hosted LLMs or external LLMs, you still need to use some sort of vector database. Again, it could be an externally hosted one. It could be a self-hosted one. A common issue there is data consistency, pipeline coordination, storage. Then, of course, then hybrid, जहाँ पे ये सारी problems आ जाती हैं, and then the coordination between all of these. There wasn't enough space, so I didn't add traditional ML models. But then, if you think about classifiers, you think about object detections, you think about all of these other types of models that we have. उनके भी same problems हैं, right? Like resource bound operations, intensive CPU usage, intensive memory usage, sometimes even another common one that I missed here is extensive GPU usage, right? So ये common problems आ जाते हैं, and you will notice something that it's a matter of available resources that you can provide and actually assigning them, right? And overall, managing the overall infrastructure. So ये सारी जो problems हैं, they sort of fall into that one area जहाँ पे वो similar issues हैं. So if there are many approaches available out there, but one that makes sense when you're growing really, really fast is Kubernetes, right? Kubernetes has been designed in a way, and not thinking about AI right now, just designed in a way that it can provision, scale, downscale, and assign resources to your application based on your needs and how you've configured it, right? तो एक वो static system नहीं बनता. But before I go into that, हम detail में जाएं, I just want to do a quick recap कि Kubernetes है क्या. Kubernetes is a container automation and orchestration framework that lets you manage and deploy your own services as containers in these concepts that I'll go into. लेकिन main चीज समझने वाली यही है कि if you've containerized your app, if you've designed your application first, you've isolated it, and then you've containerized it, it lets you play around with the scale of these containers, right? आप जो है ना, अगर आपने एक image बना लिया, you can immediately start scale it to like 100 instances of applications or pods running those containers, right? Kubernetes is designed to be used designed to be simple, modular, and declarative. Simple की मैं guarantee नहीं दे सकता. It depends on who you ask, but if you just focus on the core essentials, it can be very simple to use, right? There's a bit of a learning curve, but once you get past that, it can absolutely simplify large complex workflows with minimal amount of configuration. It also gives you full control over the scale, the provisioning, the compute, networking, and all sorts of resources that you can assign your applications. And it also comes with a very comprehensive API, right? That lets you query and manipulate pretty much everything in your infrastructure throughout the organization, which lets you build interesting automations around Kubernetes, right? You can build, you can either use built-in monitoring tools, or you can, build your own monitoring system around it, which can help you detect and rectify issue, really quickly. And all of this is based around some primitives of pods, services, volumes, operators, replica sets, bunch of other things. मैं Kubernetes की basics में ज़्यादा नहीं जाऊँगा. I would hope कि a high level understanding would get you the concept that I'm trying to convey today, right? And since we are not going into code too much, just simply understanding the high level approach would allow you to jump into code and the Kubernetes configuration when you're ready, right? There are tons of amazing Kubernetes tutorials already available. But again, my point is to drive home the point how it can help you. Another thing that I've decided as part of the talk today is, while there's so many applications or different types of AI applications out there, अगर हम एक challenges पे focus करने की कोशिश करेंगे, it will be very hard and we will run out of the time. So I decided to focus on the most common type of AI applications today, which is external API integrations, right? Where you make an API call to Claude, Gemini, ChatGPT, whatever, right? That will give you a starting point जहाँ पे आप understand कर सकते हो कि अच्छा, these are the basics of scaling, and these are the common AI or the common scaling problems that I face as part of building this AI application. And some of those concepts then can help you easily transition over to designing infrastructure when you deploy your own custom models or self-host your infrastructure. So let's move on. So for Kubernetes, there are tons of tools, tons of strategies and other platforms for scaling systems with Kubernetes. But for today, we'll focus on 3 simple approaches, 2 of which are built right into Kubernetes, right? So you don't need to pick external tool. But the third one, I think, also makes sense for some custom use cases, right? These 3 approaches, if used correctly, can solve most of the scaling challenges for AI applications today. I'm just going to quickly check if there are any questions so far before I move on, क्योंकि हम अब थोड़ा सा complexity level बढ़ने वाला है. अच्छा, let's move on. Right. तो अब scaling strategies में हमारे पास 3 strategies आ जाती हैं, right? Vertical pod autoscaler called VPA, horizontal pod autoscaler HPA, and Kubernetes event-driven autoscaler KEDA. तो इनमें बहुत minor difference है. Let's see what it is, starting with VPA. What VPA does is it adjusts the CPU and memory for pods. What does this mean? इसका मतलब ये है कि आपकी जो भी एप्लीकेशन है, ठीक है, डिपेंडिंग ऑन यूज, it can either increase the RAM and CPU assigned to it, or it can decrease it अगर usage उतनी ज़्यादा नहीं है. ठीक है? The way it works, it first calculates the optimal resource values by analyzing historical metrics. If I remember correctly, what it does is it basically looks up to 8 days of past historical information. कि आपने पिछले 8 दिनों में आपकी एप्लीकेशन की यूजेज क्या थी, उसके हिस्टोरिकल मेट्रिक्स क्या थे, सीपीयू यूजेज क्या थी, एंड देन with that it sets 2 parameters. One is the target utilization level, and the other is the minimum or the maximum amount of resources that should be allowed for each pod. And when the utilization of a pod exceeds the target, the updater of the VPA will automatically increase the resources allocated to the pod, right? It basically monitors कि क्या अभी usages, अभी क्या recommendations है, right? And then it replaces the pods already as part of the service. It replaces the individual pods with new pods with higher or lower resources. When the usage drops below the target, VPA will reduce the resources, but if it goes beyond the target, it will assign more resources. So basically, it allows you to scale up and down the resources used by individual pods. Next is HPA, which is an alternative to VPA. Instead of adjusting the resources of a single pod, HPA adjusts the number of pods in a deployment, replica set, or stateful set based on the current observed metrics of like CPU or memory utilization. So basically, it's based on the current workload of the application, right? So the use cases for that is kya current resource utilization hai, and if you see an increase or decrease in the traffic of the application, right? Similar to VPA, it scales both up and down. Like in this case, either it increases the number of pods or it decreases the number of pods. And this is the most common and the widely used pattern, right? When most people talk about scaling pods or applications with Kubernetes, this is what they mean. Finally, the third one is Kubernetes event-driven autoscaler. अब जो autoscaler है, it's sort of like a mix of both VPA and HPA in the sense that it does both horizontal and vertical scaling. लेकिन जो differentiator है वो ये है कि HPA और VPA जो है वो Kubernetes की metric जो built-in metric primitives हैं उन पे based है, right? वो it looks at things like resource utilization mainly कि CPU memory वगैरह कितनी use हो रही है और उसकी base पे करता है. But not all applications not all applications CPU and memory usage is a good indicator, right? So sometimes you need to rely on external metrics or custom events ये जानने के लिए कि हमें इसको किस तरह scale करना चाहिए, right? And that's the whole point of this event-driven autoscaler, right? It focuses on, or the main point is that you can integrate custom events and metrics into it. And some use cases for this is like event-driven architectures. अगर आपका system already message queues या event buses पे based है, this makes a lot of sense. You can just plug into that, and that can give you that can provide the relevant metrics जो कि autoscaler या Kubernetes को बता सकता है कि जो है ना, let's prepare for an estimated increase in traffic or activity or usage, so let's scale it up. If it goes down, let's scale it down. Another is when you want serverless style applications, right? So if you're familiar with Cloud Functions, Lambda, or other serverless applications, what happens is the application is only alive when there is a need to run a certain piece of code or a program or anything, right? But after that, it dies down and you get you don't get billed at all. So basically scale to zero का जो concept है. And the third use case is when you have workloads that are determined by data availability. What does this mean, right? So आपके पास there is a category of applications जहाँ पे the workload is based on not the actual traffic coming into the application, right? The workload is determined कि किस क्या amount of data है. This is sort of related to message queues. लेकिन this also means like ML pipelines जहाँ पे आपने अपनी model training वगैरह करनी है. If you use Kubernetes for something like that, तो the system is only alive while training. It's only alive जब तक कि वो पूरी training कर नहीं लेता, when the whole data set is not processed. इसी तरह आपकी जो भी inference requests होंगी, even audio, vision, anything. So while we only scratched the surface today, हमने सिर्फ 3 systems की बात की है, sorry 3 strategies की बात की है. There's so many other tools out there, right? There's Sheldon Core and Kser, which are the like really popular ones, but then you also have these hosted runtimes like TensorFlow serving and NVIDIA Triton that allow you to sort of just they just take care of the whole scaling problem for you. Again, we didn't get a chance to go all of these, and we didn't get a chance to go into more complex use cases, but we can definitely do a more detailed hands-on workshop in the future, either online or in person. That's it for my talk. I'm gonna field some questions. देखता हूँ कोई questions हैं, and if not, then we can move on.
So first of all, thank you so much, Sheharyar, for an insightful talk. अगर आपके जो भी questions होंगे, so आप share like comments में share कर देना, and we'll highlight them on the stream as well. So अगर in case नहीं हो गया तो मैं थोड़ा सा start करता हूँ मैं अपने side से. तो शेहार, जो आपने Reddit की post आपने जो share की थी, right? जिसमें वो एक देख रहे थे कि हमने कितनी हमारी कॉस्टिंग हमारी हुई थी ओपन एआई की एपीआई की यूजेज से, जिसपे वो कहते थे कि हमने फिर उसको लाइक मिनिमाइज किया था टुवर्ड्स फॉर लाइक $200, राइट? सो आई वाज लाइक वंडरिंग कि अच्छा like what are the benefits can an organization gain like by investing in a custom built self-hosted LLM? Like I understand कि this is something very like जिन companies के पास बहुत ज़्यादा budget होता है, बहुत ज़्यादा revenue होता है, they can probably like afford something like a custom build. But what are your thoughts on it? Like how can a custom model like become a competitive advantage, or क्या इसकी long term cost implications है compared to like using a Gemini API or an OpenAI API?
ठीक है, that's a very good question. तो अब इस क्वेश्चन के ना 2 parts हैं, राइट? मैं दोनों चीजें ना क्लैरिफाई करना चाह रहा हूँ. सबसे पहले कि the example that I gave here was the user was trying to do everything with LLM, right? Which is a bad approach, which is not something you should do. यहाँ पे उसने एग्जाम्पल दी है कि वो जो है ना फोन नंबर्स भी एक्सट्रैक्ट कर रहा है, प्रोफैनिटी चेकिंग भी कर रहा है, रिफॉर्मेटिंग जेसॉन भी कर रहा है, टेक्स्ट अपर केस वगैरह, मतलब बहुत सिंपल ऑपरेशंस कर रहा है व्हिच डू नॉट मेक सेंस. अगर आपके पास एआई के यूज केसेस भी हैं, देन यू शुड हैव अ फोकस्ड एआई टूल जो कि वो प्रॉब्लम सॉल्व करे, एंड यू शुड हुक इनटू दैट एंड ट्राई टू यूज दैट. लेकिन जो आपकी बड़ी एआई कंपनीज हैं वो इस अप्रोच को नहीं फॉलो कर रही, राइट? बिकॉज ऑफ द थिंग्स आई टॉक्ड अबाउट टुडे, लाइक विजिबिलिटी, प्लेटफॉर्म इफेक्ट, ऑल दैट. उनका गोल ये है कि हर कोई इन्हें ही यूज करे, एंड देव ट्रेन्ड देयर सिस्टम्स ऑन बिलियंस एंड ट्रिलियंस ऑफ पैरामीटर्स, राइट? तो उनका मकसद ही ये है कि दे वांट टू मेक दीस सिस्टम्स वो इसको जेनेरिक बना रहे हैं. इसको जेनेरिक बना रहे हैं कि हर कोई यही यूज करे, ठीक है।
ठीक।
तो सबसे पहले आपने ये देखना है कि आप क्या प्रॉब्लम सॉल्व कर रहे हो एआई से, राइट, एंड इफ इट मेक्स सेंस कि आपको एक पूरी कस्टम सोल्यूशन की जरूरत है अभी कि नहीं, राइट। Your solution has to be based around the problem, not the problem has to be based around the solution.
Makes sense.
वो कहते हैं ना, to everything looks like a nail to a hammer. तो वो वाली हमने अप्रोच नहीं करनी, हमने पहले समझना कि हम प्रॉब्लम क्या सॉल्व कर रहे हैं। अब आप रियलाइज कर लेते हो कि अच्छा अब हमें एलएलएम बनाने की जरूरत है फॉर वट एवर रीजन, या हमने अपना कस्टम होस्ट करना है, राइट। व्हाट यू शुड डू इज अगेन यू शुड लुक एट द प्रॉब्लम सेट, और आपने ये देखना है कि आप एलएलएम को क्या उन स्पेसिफिक यूनिक चीज पे ट्रेन करो कि वो एक जो आपकी जो कोर प्रॉब्लम है उसको अच्छे तरीके से सॉल्व करे, राइट, देन इट मेक्स सेंस। तो you don't necessarily have to compete with these large companies, large AI systems. आपने ये देखना है कि क्या आप अपने टूल्स जो है अपने एलएलएम को अपनी प्रॉब्लम फोकस्ड बना सकते हो कि नहीं, एंड इट डजंट हैव टू बी सुपर एक्सपेंसिव, राइट। यू डोंट हैव टू स्पेंड बिलियंस ऑफ डॉलर्स लाइक दीज कंपनीज। आपके पास ओपन सोर्स मॉडल्स हैं एंड यू जस्ट ट्यून देम अकॉर्डिंग टू योर नीड्स एंड यू गेट इट गेट्स द जॉब डन।
So I guess like more or less जो majority of the companies हैं, they can उनकी majority of the use cases जो हैं वो like open source models को use करके ही do you feel like कि उनके use cases जो हैं वो more or less handle हो सकता है by using open source models if they want to be cost effective.
यस। तो अगर फॉर एग्जांपल हम इसी एग्जांपल में से कुछ यूज केसेस देख लें जो यूजर ने जो चीजें लिखी हैं, ठीक है। रीफॉर्मेटिंग जेसन के लिए तो जैसे एक प्रॉब्लम है, you don't need AI at all, right? Tools, simple functions exist करते हैं, simple tools exist करते हैं that will format the code for you. So ये upper case वाली example मैं already दे चुका हूँ। Extracting phone numbers from emails, ठीक है, इसमें भी अब 2-3 कैटेगरी की चीजें आ जाती हैं। एक सिंपल आप regexes यूज कर सकते हो, या आपके पास कुछ trained models भी हैं, ठीक है। आप assume करो कि the user is maybe taking an image of some text, ठीक है, और वो उसमें से आपने जो है ना फोन नंबर्स और एक्सट्रैक्ट करना है। देन यू हैव डेडिकेटेड ओसीआर टूल्स एंड मॉडल्स दैट यू कैन यूज जो कि वो ऑप्टिकल कैरेक्टर रिकग्निशन करेंगे एंड देन यू कैन पास इट इनटू, आप फिर वो टेक्स्ट एक्सट्रैक्शन, फोन नंबर या ईमेल एक्सट्रैक्शन के फंक्शंस डायरेक्टली कॉल कर सकते हो, या आप उसमें कोई एडवांस्ड लगा सकते हो मॉडल लग सकता है उस केस में, बट इट डजंट हैव टू बी एलएलएम, राइट।
ठीक है, सेंस। एक मेरा एक और क्वेश्चन था इसके सेंस में कि अच्छा जैसे हमने HPA और हमने VPA की बात की, तो so like both of these strategies like they're like very influential in like scaling your application, right? Like for a machine learning inference service, like it's like pre-trained model है जो कि एक decision लेता है based on the data it has never seen before. तो like a quick आप बता like इसमें आप क्या scaling strategy आप recommend करेंगे for that service? क्या अच्छा इसके लिए HPA होना चाहिए या इसके लिए VPA होना चाहिए?
अच्छा, let me try to understand your question first. I guess the question is again is grounded in the resource utilization, या कोई भी external metric हो सकता है।
हो सकता
मैं पूछ रहा हूँ।
हाँ जी, हो सकता है।
अच्छा, तो अगर तो सिंपल रिसोर्स यूटिलाइजेशन पे बेस्ड है ना, तो you don't need to go for CADA, you can just use VPA and HPA, right? अब HPA और VPA में क्या यूज करना है, उसमें आ जाता है कि यूजुअली HPA makes more sense, right?
सही।
VPA sorry HPA के केस में ये होता है कि you just increase the number of nodes in your application, you just increase the number of pods and you just decrease them down, right? उस केस में ये होता है कि आपके जो ट्रैफिक बर्स्ट्स आते हैं या जब आपके पास रिसोर्स यूटिलाइजेशन आई होती है, यू ऐड वन मोर सिस्टम और विदाउट एनी डाउन टाइम, विदाउट इविक्टिंग एग्जिस्टिंग पॉड्स, आपने नए एप्लीकेशन हैंडलर्स इंट्रोड्यूस कर दिए हैं जो कि अब वो आपका एक्स्ट्रा लोड उठा सकते हैं, ठीक है। This makes more sense from a usability POV, और इसमें चूंकि आप existing resource को evict नहीं कर रहे, the uptime in the sense is more reliable and makes more sense. ठीक है.
ठीक.
So VPA के use cases, before I go into that, HPA is the most common one for this very reason. ठीक है. तो आपके पास एक एप्लीकेशन है, वो मल्टीपल चीजें हैंडल कर रही है, और जब लोड बढ़ता है तो उसने 2-3 सर्वर्स और ऐड कर दिए. लोड उसने हैंडल किया, लोड कम हुआ, देन इट रिवर्ट्स बैक टू और डाउन स्केल्स बैक टू 1 or 2 पॉड्स जितने भी पिछले थे. VPA मेक्स मोर सेंस जब आपने व्हेन एक्चुअल रिसोर्स यूटिलाइजेशन इंक्रीज करने से एक बेहतर आपको रिजल्ट मिलता है कंपेयर टू हॉरिजॉन्टल स्केलिंग. लेकिन उसकी डाउन साइड ये होती है कि वो एग्जिस्टिंग पॉड्स को शट डाउन करता है. ठीक है. तो वो फिर देयर इज लाइक अ लैग, और देयर इज एक स्टॉप आता है उसमें कि बिफोर इट कैन हैंडल मोर रिक्वेस्ट्स. ठीक है.
ठीक है.
लेकिन अगर तो आपके पास कस्टम मेट्रिक्स हैं और कोई एक्सटर्नल रिसोर्स है, कोई कस्टम आपके पास वो है इवेंट्स जिन पे आप रिलाई करना चाहते हो टू डिटरमिन के सिस्टम स्केल करे या ना करे, उस केस में केडा इज द ऑब्वियस आंसर, राइट? यू जस्ट स्विच टू दैट. अच्छा, अभी देयर इज अ गुड रेलेवेंट क्वेश्चन हियर, जहां पे ये क्वेश्चन ये है कि कैन यू शेयर रियल वर्ल्ड एग्जांपल्स वेयर केडा वर्क्स बेटर देन एचपीए फॉर स्केलिंग इन्फरेंस जॉब्स? इसकी अगर हमने इसको एक सिंपल तरीके से, मुझे कोई एग्जांपल दूं मैं, तो उसमें ये होगी कि पहली चीज मैं ये क्लैरिफाई करना चाहता हूं कि इनमें से देयर इज नॉट वन better than the other. It is the approach and the requirements that you're trying to solve for. अगर आपका AI सिस्टम इतना सिंपल है जहां पे it just does some computation and returns some result, HPA would do the job, right? You do not need to go for CADA. लेकिन इस स्पेसिफिकली इन्फेरेंस की बात की है, राइट? सो अज्यूमिंग कि आपका एक इवेंट ड्रिवन आर्किटेक्चर है या आपके पास एक बैकलॉग आ रहा है टास्क का, राइट? सो यू अंडरस्टैंड कि अब ये प्रॉब्लम किस तरह इंक्रीज होने वाली है सिस्टम के लिए. सिंपली रिलाइंग ऑन दोज मेट्रिक्स कैन हेल्प यू स्केल बिफोर यू इवन गेट टू द मॉडल इन्फेरेंस पार्ट, राइट? यहाँ पे बहुत एक वो चीज एक ना वो समझने वाली है. यूजुअली दूसरी एप्लीकेशंस में जब उसको रिक्वेस्ट आती है और टास्क आता है एंड इट स्टार्ट्स प्रोसेसिंग ऑन इट, फिर सीपीयू और रिसोर्स यूटिलाइजेशन हाई होती है, राइट? विद दिस यू कैन स्टार्ट प्रिपेयरिंग फॉर इट बेस्ड ऑन जस्ट द इवेंट्स और द बेस्ट और जस्ट द इनकमिंग रिक्वेस्ट बिफोर यू इवन हैड अ चांस टू प्रोसेस इट, राइट? सो दैट इज जस्ट वन वे. यहां पे आप लोगों ने नोटिस की होगी कि मुझे ये डिस्क्राइब करना मुश्किल इसलिए लग रहा है क्योंकि इट कैन इंटीग्रेट विद एनी कस्टम इवेंट, ठीक है? सो इट रियली डिपेंड्स अ लॉट ऑन द यूज केस यू हैव, राइट? आपके यूज केस के ऊपर अब वो बड़ा मैटर करेगा कि आप ये इवेंट ड्रिवन ऑटो स्केलर कैसे सेटअप करोगे, कैसे इंटीग्रेट करोगे, कैसे कॉन्फ़िगर करोगे.
ठीक है. So we'll wait for like 1 or 2 minutes.
Yeah.
Just
Yeah, let's wait for a couple of minutes to see if there are any other questions. If not, we can still wrap this up. And while we wait for questions, what we'll do is let me just quickly go over these links. After this talk, I will upload. After this session, I will upload the slides to this link. This link is not live yet, but this link will be live in a couple of hours. And you can find more of my talks at this link, sheharyar.io/talks. If you want to reach out, you can just email me at hi@sheharyar.io, and I'm available all over the internet with this username at sheharyarn. So we do have one more question, which is, which of these scaling strategies is most cost efficient for GPU clusters, given that idle GPUs are expensive, right? इसके अंदर जो सबसे आइडियल मेरे ख्याल से होगी ना, अगेन इफ यू आर गोइंग ऑन रॉ नंबर्स, that would either be HPA or KEDA, right? If your application is not at a scale level जहाँ पे आपको multiple nodes की जरूरत पड़े, I guess then VPA would make more sense. लेकिन generally when you're at a level where you need Kubernetes for scale, HPA and KEDA makes more sense. For specifically GPU clusters, given that idle GPUs are expensive. अच्छा, इस केस में ये है कि you can, for very simple use cases, again very simple use cases, HPA would do the job for you. But KEDA is more suited towards ML workloads, right? Because there are so many other integrations and metrics to choose from. We didn't even get a chance to for a basic implementation जहाँ पे आप सिर्फ कुछ GPUs के साथ काम कर रहे हो, these two would do a good job. But for more advanced use cases, I would probably go with another tool like Kserve or Seldon. उस केस में उनका ज़्यादा sense बनेगा. But since we didn't get a chance to talk about those today, we'll probably talk about that in a later session. ठीक है, I think if there are no other questions, we can wrap this up. Again, you can reach out to me at this email or contact me on Twitter, GitHub, LinkedIn, everywhere. My username is Sheharyarn. You can see my other talks on Kubernetes, Docker, a bunch of other cloud technologies at this URL. And this URL will be live with the slides in a couple of hours. And I'll also share them with Salman so he can post the link to your WhatsApp or I think Facebook or other socials. Okay, thank you so much, and thank you for having me. Assalamu alaikum.
Yep. Okay. Thank you so much, Sheharyar. Again, just as Sheharyar said, we will be having वो अपनी स्लाइड्स जो हैं वो अपनी डेडिकेटेड लिंक्स पे शेयर कर देंगे. हमारी एक व्हाट्सएप कम्युनिटी है जिसका मैं लिंक जो है वो हम आपके सोशल पे भी शेयर कर देंगे. But yeah, thank you so much for all of you for tuning in. We'll see you in a later session. Allah Hafiz. Bye-bye.